investigation is if you double the radius, so we're talking about 2r, of a sphere, you double the surface area. Okay, so remember, just recall the surface area is 4 pi r squared. Okay, so let's make one sphere, let's go 2, and one sphere, let's go 4. Okay, a little bit different than the 1 and the 2. So let's do the surface area of the first one. It's number 1, this is number 2. 4 pi 2 squared. This is 4, this is 16 pi. And I'm going to actually leave it as pi for right now. In the older grades, you're going to get more used to seeing the pi rather than actually calculating it. So let's do the surface area of number 2. 4 pi and then 4 squared. So 4 squared is 16. 16 times 4 is 64. Okay, so this is 64 pi. So doubling the radius does not double the surface area. 16 does not, 16 times 2 is only 32. It is not 64. This actually is a multiple of by 4. And the second example, which has a larger surface area? A sphere with a radius r, or a cube, let's put a box around there, with the edges of length 2r. Okay, so sphere with r. So let's calculate surface area equals 4 pi r squared. So we don't actually have to sub in the r to the radius because that one's fine. That one's already simplified. Okay, and now let's see if we can solve this for 2r, 2r, and 2r. So we know that the surface area of a cube, there's 6 faces, and because all of these are squares, they're just 2r, 2r times 2r, okay? Because this is just length times width, but it's really length squared because the length and the width are going to be the same. So we have 2 times 2, which is 4, r times r, I get 4 r squared, and 6 times 4, I get 24 r squared. So let's go back over here. We can't compare these yet because one is 24r squared, and this one here, we do have an r squared, but we have a 4 pi. So let's just multiply 4 by pi. I get 12.56 r squared. So what's bigger? Which one has the largest surface area? Larger. 12.56 r squared or 24 r squared? Definitely the cube with edges of length 2r has a larger surface area.